चश्मा पहन लेता हूँ ये वाले। बोलना भाई।
Check, check, check.
Okay. I think we can start. So we have discussed scene graph instances, refining scene graph instances yesterday, and we are going to start point instances today and point instancing. So authoring point instancing. In this lesson, you'll learn how to define point instancer, prims, understand the difference between point and scene graph instancing, and implement efficient large-scale scene representations. Here's what we'll accomplish. Learning objectives. By the end of this lesson, you'll be able to understand the concept of a point instancing and how it differs from scene graph instancing. Create point instancer prims from external data sources. Oh, JSON, CSV, etc. Create point instancer properties, including prototypes, positions, orientations, and indices. Apply point instancing techniques to real-world production scenarios. Here's an outline for the lesson: Introduction to point instancing. Exercise authoring point instancing. Okay, pretty straightforward. Introduction to point instancing. What is point instancing? Point instancing is implemented as a schema in OpenUSD, the point instancer prim type. What does this mean? As a schema.
Schema.
Schema. Okay. Point instancer uses array attributes to describe points in 3D space. So point instancer uses array attributes to describe points in 3D space. Additionally, explicit prototypes represented by prim hierarchies in the stage are specified as relationship targets to point instancer by combining the points, prototypes, and an index array to map the points to prototypes. By combining the points, prototypes, and index array to map the points to prototypes, OpenUSD is able to handle hundreds of thousands of repetitions very compactly in vectorized format. See USD geom point instancer details documentation about point instancer. Mm-hmm. Mm-hmm. Mm-hmm.
Point instancing.
Designed to scale billions of instances, which motivates the choice to split the per instance transformation into position,
Wait.
orientation, and scales rather than 4x4 matrix per instance. In
Alright.
addition to requiring fewer bytes. I don't know what the fuck that is.
Schema. What does schema is an infrastructure API for authoring and reviewing data. Finding uses are to describe points and additionally specific types used for in hierarchies that specified as relationship.
It's a prim type, built-in USD prim type.
Yes.
Point instance.
Yes.
So it's implemented as a schema.
The repetitions very compactly in the vector form
Uh,
compared to scene graph instancing point instances can be less user-friendly and trickier to define because most of the same description is written away in large arrays that are not as defined disabled nothing was control items where the overhead of an instance outweighs the benefit of dealing what the machine leaving think about leaving and tree you might have 100 tree one tree which is sorted down the path of leaving through and always to find it walk through the concrete example of poison and peanuts with the box. A single box may not have a lot of packaging peanuts, but they are not crumbs. We want to use it much in there. Okay, so define conditions.
Compared to scene graph instancing, point instancer can be lesser user friendly and trickier to refine because most of the scene description is hidden away in large arrays that are not as human readable. Point instancing is designed for massive number of simpler items where the overhead of instance outweighs the benefit of reuse. What does this mean? Think about leaves on a tree. You might have 100,000 leaves on a tree. If you start down the path of using scene graph instancing for this, you would need to define each leaf repetition and uh, you would end up with 100,000 instanceable prims. Leave 00001. Okay. Need this in your scene graph. Is this useful data for anyone? That's where point instancing is a clear winner. How does it work? We will talk through concrete examples of how point instancing packaging peanuts within a box works. A single box may not have a lot of packing peanuts, but they are not trims. We want to enumerate in our scene graph. Relative prototypes of pine tree and oak tree. And inside it, array describes produce, position, how to rotate. Okay. Um, Okay. But they are not terms and we want to enumerate in a scene graph. Okay. So this is the example over here. Default from the point instancer, packing peanuts, relative prototype, prototype peanut 1, peanut 2. Int proto indices 0001. Hmm. Oh, okay. I don't understand this USD code.
Just go through, like, dude, you're not even reading the whole thing. That's why you're not able to understand. Just go through the whole thing.
Hmm.
There is information
Point
written below.
point is what?
The information is written below.
Okay. Point instancing is a schema based instancing solution So we need to start by defining a point instancer prim. The point instancer includes the following mandatory properties. Prototype. A relationship targeting the prim hierarchies that point instancer should use as instance prototypes. The prim a relationship targeting the prim hierarchies that the point instancer should use as instance prototypes. Okay. Proto indices declares an instance of a prototype. Each element in the array maps a point to prototype ID. So why is it 0001?
What is the take the array index of prototypes? It takes the array index of the prototype. Zero is peanut zero. Dude, just go through the whole thing. It is going to tell you why are we doing that.
Declares an instance of a prototype.
Asking question before reading furthermore.
Each element in the array maps a point to a prototype ID. Positions the points in local space where each instance is located. Orientation and scale are optional but can be used to fully pose each instance. ID is an optional attribute if you want explicit control over the integer ID of each instance. Otherwise, each instance ID is inferred from the element index in the proto indices array. Example, index 0 in proto indices is instance ID 0. Orientation and scales are optional but can be used to fully pose each instance. Orientation and scale are optional but can be used to fully pose each instance. IDs is an optional attribute. IDs? Where is IDs?
It is given below.
No, I know it's given below, but where is it in the code? It's saying indices can be
No,
zero.
below, go down. Brother, go down. This is what it is talking about IDs. Like over here, querying and over. Just go through the whole thing, you will get it. Just go through. You are asking question at each and every point. That's why just go through the whole thing. It is talking about an
ID
yeah.
ID is an optional attribute if you want to explicit control over integer ID of each instance. Otherwise, each instance ID is inferred from the element index in the proto indices array. Okay. Each instance ID is inferred from elements in example index 0 is proto index. This is instance ID 0. As a result, best practice, we define prototypes under a scope as a descendant of point instancer. Unlike implicit prototypes in the scene graph instancing, you need to explicitly define each of the prototypes for your point instancer. We purposefully use an over specifier for the scope to keep the prototypes from being traversed by default traversals. This is a way that we can signal that these prototypes don't need to be rendered and should be skipped. The instances are typically what we want rendered. What the fuck does this even mean? Let's spend a little bit of time breaking down how points are mapped to prototypes. In the example, proto indices show 0001. The integers represent the indices. In the prototypes, array 0 maps to prototypes peanut 01 and 1 maps to prototypes peanut 2. This means the first 3 points are using prototype peanut 01. Oh, okay. Oh, okay. Mm-hmm. By default traversals to keep prototypes from being traversed by default traversals. This way that we can this is the way that we can signal that these prototypes don't need to be rendered and should be skipped. The instances are typically what we want rendered. Let's spend a little bit of time breaking down how points are mapped to prototypes. In the example, proto indices show 0001. The integers represent an indices in the prototypes array 0 maps to prototype peanut 1 and 1 maps to prototypes peanut 2. This means that the first 3 points are using prototypes peanut 1, the following point. Okay. Querying and overriding point instances x1, x2, x3, x4, x5. Many of the point instance properties are array attributes. Many of the point instance properties are array attributes. There's no easy way to ask us for information about individual instances here. Much of information about individual instances here. Much of the data has been vectorized. You potentially have giant arrays of positions, orientations, scale, etc. You have to index into those arrays yourself to query data about a particular instance or to override any of them. Dude, I think I cut my eye.
Oh my god. Cut. Cutter. Oh really?
I don't know.
Oh really?
Mm. Yeah. Okay. What the fuck does this mean? Many of the point instance properties are array attributes. Okay, there is no easy way to ask us for information about individual instances here. Much of the data has been vectorized. What does this mean?
They are talking about that each and every position has been already compiled basically. So so let's assume we have orientations, right? Just take a look at the code. You will understand what they're talking about. Take a look at the code.
Mm-hmm.
So over here we have like point 3f point dot time samples. So this is your property attribute
Mm-hmm.
point instance attributes one two blah blah blah. So at first time sample you have an array, right? So that array
Mm-hmm.
is mapped with the positions that we discussed upon in the above code, right? So on the first time sample x1 x2 x3 x4 x5, right, it will be directly mapped. And again for the quoth orientation or time sample for the other time sample for all the time one, 2, 3, 4 until 100, so it's all also mapped somehow.
I don't get it. What you're trying to say? What is this? 1 to 100. What is this? Time samples.
Yes, now in that,
And
that's an array. That's an array.
yeah, this is an array.
No, in one you have an array.
Oh, there's an array. Yeah.
That
Okay.
array
Array of what?
array of point instances. Point
Okay.
instances that is directly mapped with your positions.
Mm-hmm.
So in point instances you can, so let's say you created some instances, right? So when you created those instances, you have an index 1, 2, 3, 4, 5. So by default, point instancer will directly map those array indices or indexes
Mm-hmm.
onto the time samples as well. So for
Mm-hmm.
example, let's say one in the first time sample, you have 0, 0, 0, 1, right?
Mm-hmm.
In that you are picking up the first index of your point instance. Like what is that point instance pointing to? Let's say the point instancer is pointing to the first file over
Yeah.
here.
Prototypes
Yes.
period 01.
So it's going to directly map it out.
Mm-hmm.
Right now this is the most layman, like this is a high level example. Right now if you want to change the position uh, of that prototype in multiple angles, right, in the above x1 x2, like no, not this one, the second image, x1 x2
Mm-hmm.
x3 x4 x5. So that is the properties of your point instancer. That x1 indicates that the prototype will stand 180 degree or in a certain direction. X2
Mm-hmm.
indicates that the point will be in a certain direction. X3 indicates that the prototype will be in a certain direction, and vice
Mm-hmm.
versa. And you can do it for maybe let's say 100 positions, or how
Mm-hmm.
much you want. So it says many of
Mm-hmm.
the point instance properties are array attributes. That's what it means over there. The first line. Many of the point instance properties are array attributes.
Mm-hmm.
Right. So there is no easy way to ask us for information about individual instances here. Like
Mm-hmm.
if you want to ask about what is the position of that at this point, it becomes
Mm-hmm.
really difficult to ask it because most of the data has been already in an array format, like vectorize. What do you know what does vectorize mean over here?
No.
It's been computed into a matrix.
Okay.
So you have different positional matrix that exist for a specific index.
Mm-hmm.
So at a given point in time, what are the values that you can correlate to in that on that index, and that's get computed for that index. That's what it is saying. So let's say you have on the first time sample on the first index you had two matrix. First one was,
Matrices.
yeah, first one was something about where would be the prototype in horizontal offset, and second matrix would be where would be the prototype in vertical offset.
But where are these matrices inside this?
Yeah, inside it. inside it. Like we are not, they are not showing us because it's pretty computer intensive, and we
I
cannot like
see.
understand it over here directly. But that's what it is trying to say us.
Wait, let me look at what perplexity is saying. Think of point instancer like three or four big parallel arrays in the code, not a bunch of separate objects that you can poke individually. The vectorized arrays idea, point instancer stores data like this. Positions, array of all instance positions, array of all instance positions. Orientation, array of all instance rotations, array of all instance scales. Okay. Oh, and proto indices array saying which prototype does instance I use. In code terms, it's closer to positions, orientations, scales, proto indices, x0, y0, x1. By indexing to big arrays yourself. So if you want the position of instance 10, one big array per property, not one structure per instance. Why you can't do right now? It does not provide sparse updates on these arrays. But what are these arrays doing? Like they are just giving the positions, right?
Yes.
Position, orientation, scale.
Yes.
So what are we trying to do here? I'm not able to understand.
You're trying to point to different orientations at a specific time. Look at the peanuts. Look at the peanuts.
Yeah, yeah,
So you can point at different orientation at a specific time. So you have x1. What is the orientation for that?
straight,
What is the orientation for x2?
horizontal.
Horizontal. When you compute it along
Mm-hmm.
the indices, right,
Mm,
along a time space, you can map it out basically. So when you do zero, so the best part of point instancer is it maps by indices. So when you first indexed your files, right, by prototype 1 and 2 in an array, the position was already given 0 and 1,
mm-hmm.
right? And then when you compute it, so
Mm-hmm.
try to implement two matrices that will have x-axis positions for your prototype and y-axis position for your prototype.
Mm,
And when you compute it along a time sample, so like you will say, hey, on first time sample I want the positions to be the second indices or the second
mm.
index of the x-axis and fourth index of the y-axis, whatever you did over there.
What?
So imagine you have two arrays. First is
Yeah,
an array that is giving you uh, position offsets along x-axis, like
x-axis. Okay.
second array is giving you positional offsets regarding y-axis,
Mm-hmm.
and you create a time sample like over.
Mm-hmm.
So at first time sample, you can select any index that defines the
Mm-hmm.
positional offset for x and for y,
Mm-hmm.
and you can compute it basically in the background that okay, 1 2 1 2 will
Mm-hmm.
relate to that on x-axis the offset is going to be +1, and 2 will relate to that the on y-axis the offset is going to be 2,
Mm-hmm.
right? So that gives you So basically, that gives you that on the first index,
Mm-hmm.
the first time frame. This is how the object will be oriented in
Yes,
your instance.
I see.
Point toward it. So that's what they are trying to do over here.
Oh, I see. It's if time. Ethereum might be used to. I see. Computing instance transfer. 1 minute. Okay. Come on. I still don't understand what's the goal of point instancing right now.
Just go through the whole thing, you will get it. Just go through the whole thing.
Bro, you've been saying that for like fucking.
Dude, what can I say? That's what the whole thing
This
is.
is just
It's gonna explain you as you go deeper. They're gonna explain you more as you go deeper. Right?
computing instance transforms. Wait, we read this, right? Much of the data has been vectorized. You potentially have giant arrays of positions, orientation, scales, etc. You have to index into those arrays yourself to query data about a particular instance or to override any of them. Additionally, at the moment, there is no way to sparse overrides on arrays. for the new opinion. You need to author the entire position array again for the new opinion. Hmm. A point instance or override requiring full arrays for each time sample. Okay, keep this in mind as you perform downstream override and consideration you may need to make about things like USD layer formats, that is USDA versus USDC. Computing instance transforms when you specify positions on point instancer. You're defining positions in point instances, local coordinate space. You specify positions on a point, you're defining positions in the point instance, local coordinate space. Okay. However, when USD computes the final world space position of each instance, it combines multiple transforms together. Mhm. When USD computes the final world space position of each instance, it combines multiple transforms together. What the fuck is this? I'm not able to understand what the fuck is trying to do. For each instance, USD applies the following transform in order from the most local to least local. Prototype root transform the local to parent transformation of the prototype root is applied most locally. The local to parent transformation of prototype root is applied most locally. Instance specific transform, the per instance transformation is applied next in this order. If authored, scales I, if authored orientations I, if authored positions I, point instance or prim transform, the transformation authored on the prim point instance or prim itself is applied least locally. This means that you can move an entire point instancer around your scene by transforming the point instancer prim. Sarkar is in the chat.
Crazy.
He's saying Mutesh.
Crazy.
Uh, prototype root transform, the local two parent transformation to the prototype root is applied most locally. Instance specific transform per instance transformation is applied next. Scale if author if a pod instance drop rim transform. The transformation authored on point instance rim itself is applied at least locally. What is this even doing? I don't get it. Okay, give me an example, bro. What did you understand? What is point instancing doing?
Point instancing is instancing to a point.
I knew it. I knew it, bro.
Yes, brother. Point instancing is instancing to a point only.
Now you can move entire point instance. I didn't understand anything in this page properly. What the fuck are they trying to do?
Interesting
How
question.
is it used?
I think they're gonna show you in the next exercise how is it used.
Brother, you're saying that since the beginning. You're saying,
That's
oh,
how
read
the
everything,
OpenUSD
then you'll get
works.
it. Read
That's how
everything, you'll get
OpenUSD
it.
works. In this exercise, you will learn how to create point instancer from a JSON file that emulates export data from a simulation application. Point instancing is a powerful technique for efficiently generating large number of similar objects. You will read scatter data of boxes and palettes and create a point instance of prim. This technique is essential for handling massive data sets in production and workflows. Okay, so what we have is a py file. We have exercise directory with open blah blah blah. We have export JSON. Okay, so what we are trying to do over here is create a point instance dot define that is gonna be a world and scatter world slash scatter, and then we're gonna create some prototype names. So what are the prototype names? Sorry, prototype containers. So we have a prototype prim first that is gonna be usd geom dot define. We get the path. We're gonna append our childs, and then we're gonna append our next child.
How are we creating a point instancer from a JSON file and why?
It says right over here, this technique is essential for handling massive data sets in production workflows.
But what data? What data is coming from this JSON?
I think, dude, you can take a look into the Learn OpenUSD thing. Go open your VS Code and you can take a look into the JSON file. So then we have assets that we're creating, then references, and then we are defining our prototypes. Okay. Now this is where fill in point instancer with exported data. Okay. So we have create our reference and then we set targets and then we export position data and then create indices attribute and then we have export data. Okay, so I'm assuming that the JSON will have an array of positions and proto IDs. Where is export data? Yes, I'm assuming that the point export.json has two arrays. That one of them is positions and second one is proto IDs. And then we
Hmm.
create orientation attribute. That yes, this is what I was talking about. gf dot coauth vector for vector and export data orientation. And then we'll have get from dot specifier. So did you open that JSON or not?
Wait, I'm trying to read the code first.
So the initial lines from 29 to 40 are pretty simple. It's basically creating the complete scene graph structure of the prim. But the main magic happens from line 44, oh sorry, line 49 to line 51, where you're trying to create the attributes for the positions.
Where is that file?
When VS open the VS code, right? It will be in the assets.
Source assets.
Yeah, like look, search for point export. Yeah, it's gonna be in the exercise directory and under point, the file name is point underscore export.
I don't think there's any directory called exercise.
CIR. Wait. Oh, sorry. Current file path. Oh, my bad. Just search for points underscore export dot JSON using into the Explorer, and then we will stumble.
Point what?
Point underscore export dot JSON.
There's nothing like that. Points underscore export. Okay, I've opened the file.
Okay. So what did we find? What did we?
Just orientation, position, and proto IDs arrays.
Yes, right. So, uh, where is the fucking stream going on? What the hell? So open the code side by side, like the other one. Yeah.
Mm-hmm.
So now based on this, you have your proto IDs,
Mm-hmm.
right?
What is proto IDs? Oh, like the one
Mm-hmm.
it's selecting from
Yes.
0 or 1.
Yes.
Prototype IDs.
Mm-hmm. So
Mm-hmm.
first, you use point instancer. Like this is a point instancer prim. But this is not a normal prim. We are not
Mm-hmm.
creating a stage. We are using point instancer to create and define a prim called pi. And that prim pi has some prototype prims that is going to be defined over here.
Mm-hmm.
Like if you look at the line 32
Mm-hmm.
on your stage that you have created world scatter, you're going to define some prototypes, and then you're going to append the prototypes onto your prototype prims.
Mm-hmm.
And on line 34, you are not defining your prims properly. Like what is the prim inside it?
Mm-hmm.
So first prim is gonna be cube box AO4 underscore 26 centimeter.
Mm-hmm.
So this is something that you are defining. It can be anything. You can you can define it whatever you want. But
Mm-hmm.
this is the first prim. That means the index will be 0. The index of this prim will be 0.
Mm-hmm.
Right? And then you're gonna define the asset path of that prim. Like from where are you gonna get that prim from? That is what we are doing on line 35. And once we have done that, then we're gonna use our reference magic to add the asset path as a reference.
Mm-hmm.
Similarly, our second block and the second prim and the prim that will have an index of 1 will be block.
Wait. Reference the cube box A04 to 26 centimeter asset to use as prototype. Box equals to stage define prim. Okay. What is this line doing? Box equal. They are just define. Okay, so they are just setting this prim inside box variable,
Yeah, they're
and
instancing
then
technically.
what?
They're instancing it. You since they're referencing it, they're instancing it. You remember the code.
I don't get it. Why are they instancing it? And
Point
how do you know they are instancing it? They are okay.
point
Wait.
instancer.
Wait.
That's why.
pi equals to USD geom dot point instancer dot define this. Okay. Create point instancer. Create prototype container. So they are contained this prototypes inside this container.
Mm-hmm.
And then they're referencing the cube box asset to use as okay, so they are referencing this to use the this prototype.
Yes.
So that's why they're instancing it. Okay.
Yes.
And then box asset path stage path dot parent dot parent. So what is this line doing?
This is defining the asset path. You have to define.
Inside the prototype.
No, in the variable.
Yeah, I know in the variable, but what is it like? Where is this path? Like inside what?
Why would we go look at the next line? You will figure it out.
And then reference box dot get reference add reference to box asset path.
Yes.
Yeah, that's what I was asking. So this is gonna set reference to box asset. Like this is gonna set reference this.
Okay. What? So based on these three line from line
Mhm.
31 to 36, how would you convert it? What would the converted USD code look like? Tell me.
It's basically gonna look like def of scope USD. Where's that create product container? Yeah, okay. So def of box and then curly brackets, and then inside it is gonna be uh def of cube box A04 to 26 centimeter.
We haven't defined box anywhere, first of all.
Okay, yeah, so then it's gonna be like just def cube box A0426
Mm-hmm.
and then bracket
Mm-hmm.
the metadata bracket, and then first line would be references, prepend references
Mm-hmm.
equal to this cube box A0426 centimeter USD.
Yeah, the asset path.
Yeah.
Mm-hmm.
And this is then this asset path will be defined in that prepend reference.
Mm-hmm.
And then we are going to say instanceable equal to true.
No, we won't.
Why?
Because we're using point instancer.
So we don't do that in point instancer.
We don't
Where
do.
is that written?
I know for sure because the file we are referencing will already have instanceable equal to true.
Okay, whatever. And then okay, and then metadata bracket will be closed, and then curly bracket begin.
Because the other thing,
Uh,
wait, I will tell you why. But in this code, we are not setting the box dot set instanceable true anywhere. That's why.
mm-hmm,
That's why we won't define that we won't define instanceable equal to true at any point when we
mm-hmm,
get this Python code into a USDF file. To do that, we have to always define box dot set
mm-hmm,
instanceable bracket true.
mm-hmm,
Then it's gonna do the instanceable true over here. But since we are
mm-hmm,
already using point instancer, we are
mm-hmm,
already defining our scatter prim as an
mm-hmm,
instanceable prim, right? So
mm-hmm,
we already know that whatever objects that are going to be referenced inside it will are already instanced out.
mm-hmm.
That's why.
I see.
Mm-hmm.
Fill in point in sensor with exported data,
Yeah.
required properties, prototypes, prototype, proto indices, positions. I see.
Now just go through the code and understand what how is it mapping it.
Mm. देखी जाऊंगी. Hmm. Reference the block palette A07 asset to use as a prototype. Palette equals to stage define prim prototype prim get path append child. Okay, we are instancing it over here. Palette asset path is going to get referenced over here. Fill in point instancer with exported data. Proto rel equals to pi create prototype rel. Proto rel set targets. Okay. So what is then they want us to do? I think I understand this. This is what this was doing over here,
Yes.
like this.
Yes.
This is what this is going to do, right?
Yes.
And then
So
pi dot create position attribute.
where we are basically setting our targets where the data will be mapped.
Hmm.
We have two targets. One is box, second is palette.
I see. Okay, then pi dot create position attribute export data positions proto IDs. Create orientation attribute GIF. Prototype prim get prim specifier set SDF dot specifier over.
So did you get it or not?
Yeah, they're setting the over specifier
Mhm.
on the prototype prim over here. Over, yes.
Yes.
But yeah, I know what the code is doing, and I also know how the USDA will look like, right?
Hmm.
But I still don't fucking get it. Why are we
Go
doing
up.
it? Why?
Read the line again. Go up. Go up.
Which line?
The
I
last.
know this line, right? Point instancing is powerful technique for efficiently representing large number of similar objects.
Yes.
But how is it happening over here? How?
So look up. Open the JSON.
We are just instancing the fucking thing.
Yes. So that is what we need.
Let me run the code first. Wait. Oh, I'll just ask fucking.
Run the code. So it's creating maps of all the positions that exist and for different types of orientations that you want to perform. That was exported from a different file. When you have a really large database. So for example, you want to now
What? Can you repeat again?
it's basically mapping different types of orientations that exist for that prototype or that you can map it to, I would say.
What the fuck is this?
Zoom out.
What is this?
Right.
Plane,
We are not rendering any file, I guess.
brother.
Wait, it says scenario. Dude, you are not rendering scenario.usd. You have to render scenario.usd, right?
What is this?
Reset. Wait, go back over there. Go back. It doesn't say underscore reset, first of all. And it says underscore reset over here. So you are doing something wrong.
Oh, okay, this one. Let's see now. Yes. Okay.
Now, you understand it or not yet?
Yeah, so basically, this we are referencing only one file, but we are
We are
basically converting that prototype into like different orientations
Yes, and then we are
for
mapping it.
each.
Yes, we are mapping it along different axes.
Yeah, got it.
Yes, and that's how. So now, if you want to do this basically
Hmm.
manually, then it's gonna take a lot of time.
Yeah.
First of all, and second thing is, and when you try to render it, like render this big amount of palettes or operands, it's gonna fucking break
Hmm.
your system without using point instancing.
It's gonna what?
It's gonna break your system if you are not using point instancing, because you would be
Uh,
creating duplicate objects in your memory again and again. So you see how many objects we have: one, two, three, four, five, six. I don't know how many, but we have, I think, more than 100 or 200 objects in that.
I see. Hmm.
This is what we are trying to do over here. That in a scenario where you have given multiple orientations, and you want to map it onto a single object. That's how
Hmm.
the point instancer works. That it uses the index. So best part,
Hmm.
when you arrange, since we arrange both palettes, like you can also inverse the arrangement. Like if you go in the code base
Yeah.
and inverse the arrangement, let's see what happens. Just put go up, yeah, replace 46 and 47 line. Put palette first and box. Put palette first in that.
Yeah, I know, bro.
Yeah. And then put box on the second one. Do it. Now rerun it. So now it's got.
Oh,
We will have box,
yeah.
more palettes. This.
More pallets, less box.
Yes.
Yeah, the number is inverted.
Yes.
Ah, I
How the
see.
mapping.
How does the USD look like for this?
Yeah. USD will look like in a similar manner as we saw it.
Oh, we cannot
We can
do it.
use cat USDA and then you can process.
But I know it's gonna be like a very big.
Yeah, it's going to be a very big file, but you got the gist, right? How it works, and
Hmm.
but we will still be able to see it. Like we can still see the first a couple of things over there. I would say
It was USD cat, right?
it was USD cat. You use USD cat and just name the file. Do copy relative path, and then it's gonna work. Yeah.
Okay.
Um,
Oh shit! It's not showing the full thing.
yeah. Let's
Mm.
say S dot something. Yeah. There we go. So now if we look at the first thing, remove the the most important thing we are looking for, do command F on on the cube name. Do command F on the cube name. Yes, this is the one we are looking for. So we have
Scatter.
no, yeah, our prototypes defined.
Mm-hmm. Oh yeah, over here.
Yeah.
Okay.
No, the relative prototypes. That is that the point instancer is looking for. This rel prototypes.
Okay.
Yes. So this is what maps the indices in the point instancer. So first array index will always be 0, second would be 1. And same for the proto indices.
Mm-hmm.
And when the positions comes in, they're going to map it accordingly. So like for the positions, 0, the first position index will be mapped for 0,
Mm-hmm.
like that. So that's how the point instancer works.
Mm-hmm. I see. I think I get it.
Right? So that's how, and this is the place where we use point instancing, where
Yes,
you're
got
referencing
it.
and creating different kind of orientation. The best part is it auto maps everything because it's basically pointing based on the arrays we have.
Mm-hmm. Okay. It means blah blah blah. So over here, point instancer trees. So tell me one thing. If we are saying def point instancer, okay, wait. In this code, the point instancer is scatter,
Yes.
right?
Yes.
And this is what is doing the whole thing.
Mm-hmm.
Box palette and cube box
Mm-hmm.
04, whatever this is.
Mm-hmm.
And it's saying int proto indices 0001. Okay. And this is orientations. Oh, on this is orientation coordinates.
Yes.
And this is positions.
Yes.
So what is scatter then?
Scatter is your point instancer, Prem.
Like wait.
This that Prem basically creates instances.
Scatter. Okay, so this whole thing is called scatter together.
Yes.
Ground mesh camera environment and distant light, and this is the
Why are we
scatter.
not able to see anything? Because the whole thing is mapped into the memory. That's why we're not
Uh,
able to see anything below that.
I see.
So it's mapped directly into the memory buffer. So the whole thing is,
Mm-hmm.
that's why we are not using instanceable true at any point. So you are pointing, you are compiling it. The whole thing you have compiled the whole thing, and once you have compiled the
Mm-hmm.
whole thing, you are basically creating a map. It is
Mm-hmm.
memory. So USD just gets that there is something compiled, and we have to just display it. It
Mm-hmm.
doesn't know each and every scene graph or any other component that exists.
Mm-hmm.
So we cannot, like, if you want to go downstream, if you want to make any changes into the point instancer, so point instancer becomes immutable at this point. that to do any change,
I see.
you have to you have to go and make the changes into the asset file or into the prototype, but you cannot make changes outside the point instance. Like for example, let's say you're going to pick up the whole tree block, right?
Mm-hmm.
You cannot make individual changes into the prototype. You cannot use any override function into the outside the trees uh, point instance prim. You have to go
Yeah.
inside the
So we cannot do over point instead
yeah,
over trees
yes,
or
cannot
something
over trees because it
because it's in the memory.
yeah, it's in the memory and it won't work.
I see. And in proto indices 0, 1, 0. So okay, so this is basically choosing. So 0 would be oak tree and pine. 1 will be pine tree, and then point 3f positions. And this is defining the position of these. For 0, it will be 0, 0, 0. For 1, it's gonna be 5, 0, 0. Is that right?
What come again?
Like I'm doing in over here, it's doing int
Yeah,
proto indices
yes,
0, 1, 0, 0. So this is 0 is oak tree and pine tree is 1,
yes,
right? And over here, points 3f position.
yes,
This means the position of 0, then
yes,
the position of 1, and
yes,
then position of 0 again.
yes,
Is that what it means?
yes,
Okay, and then point instancer is one prim that says place copies of these prototype objects at these
this
points.
point.
So instead of making world tree 0, 0, 1, it just makes world trees, which prototype to use, proto indices, where to place it, positions, how to rotate it, orientation, how to scale it, scales. Okay, so it's all done inside one point instancer prim. I see. A schema in USD means predefined blueprint for a type of print. So point instance has known structure, known attributes, and known behavior. USD tools renderers understand it because it is a standard schema, not random user defined data. The study guide places this content under content aggregation, specifically around using native and point instancing to optimize large scenes and even list tasks like adding prototypes to point instancer and hiding point instances efficiently. I understand it now completely. Yes, sir. Got it. So over here, relative prototypes, proto indices, point 3f, position orientation and scales over scope, prototypes. So why are they using over scope over here to group this?
You can do anything inside the point instance and not outside.
Yeah, yeah, yeah. And okay, so they have grouped this for what? Prototypes. And then what? Why have they grouped this together?
So that you can change, so prototypes, right? So they are grouping it together so that they can make changes or do override on the peanut 1 and peanut 2. Peanut 1 has some variance property, and then peanut 2 has some variance property, so that you can pick those up for your prototypes directly.
Hmm.
That's why so whatever they're doing it inside it. They're not doing it out. They're not doing it outside. That is a main catch.
Hmm.
You can play as much as you can into the point instancer, because once the point instancer is compiled, it is baked into the system's memory. And once it is baked into the memory, you cannot do any changes at that point. Well, so up the stream, the way OpenUSD flow works is, first the leaf node files are compiled, and then the files that are above that will be compiled, and the files that are above will be compiled, right? The layer by layer. So, for
Hmm.
example, you have a layer so you have a layer inside, layer under layer. So over here in the above, what we have, the prototypes and the assets files are a layer below our point instancer.
Hmm.
Play until we can play in the local layer as much as we can, but we cannot play
Hmm.
point instancer on the layer above that. So let's say layer one
Hmm.
is our assets layer, layer two is our point instancer layer, and layer three is our root layer. right? So
Mhm.
when you're importing that point instancer namespace or whatever prim that you have created into your
Mhm.
layer three, right?
Mhm.
And you say, hey, I want to override this point instance layer. You cannot do that. Why? Because
Mhm.
layer two is just pointing you to the compiled memory location of that point instance,
Mhm.
not to the individual points. That's why we cannot do any changes, and it becomes immutable at that point. That hey, nothing can be
I see.
onto over here.
Bro, there's some person in the chat.
Hmm.
Look at that.
What is he saying?
I don't understand it. Look at it.
Dude, if you are not able to understand, how the fuck can I?
But take a look at it.
Eh, Let's always. I don't know, bro.
Hmm. All right. Point instancing understood as well. Nice. Oh, it's nice, bro. We didn't do this yesterday. I wouldn't have got it. Like,
That's fine.
we're refining point instances. Oh, holy shit. Wait, bro. I need to make tea first.
Hmm.
Yes, it's going to be cool tomorrow. 20 degrees only.
Wow. Let me check my weather. Dude, today was freaking hot. Fuck me.
I went on the run today. It was nice.
You know how much was today? Today was 83, motherfucker. 83, bitch.
No, it was, I think it was the same, but today,
And
mm,
tomorrow is a bit colder. Tomorrow is 74. So yeah, that's good. Oh, because it's gonna rain, I guess. No, it's not gonna rain. On Wednesday and Thursday and
yes.
Friday. So this week it's gonna rain, dude. Fuck. If it rains, that's much worse.
Let me see if I have meetings tomorrow. Bro, they fucking changed the. Oh, what the fuck, bro? I have so many fucking meetings tomorrow. But all of them start after 12:45.
Whoa, 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 whoa.
Whoa.
Da-na-na. Dude, you know, I got this coffee Nescafe. Which one? French roast. Dude, this shit is real good.
Bram, I think I drink this one. I'll show you. Cafe Bustio.
Oh, I have heard of that.
But the ground coffee.
Yeah. Dude, I know I need to
This
get
one.
that one, but for that I need to get.
Mocha pot.
Yeah, I need to get a coffee machine and all that, and that's really
No, I just have this and mocha pot.
okay.
I make it in this. But I think now I'm kind of over it, bro. This.
Uh,
It's nice, like.
uh,
But I don't know. I'm thinking of switching up like something because I'm bored of drinking the same shit every day.
you know what you should do? You should get an espresso machine.
Sure, buddy, sure.
Yeah, bro.
I'm just getting ordering it right now.
Let's go open Amazon, motherfucker. Open Amazon. Order it right away, bitch. Look at how much is an espresso machine. Espresso machine. It's gonna.
My friend got it. My friend ordered it from Italy.
Oh, it's 140 bucks, bitch.
200. But I don't think these are nice, bro. These are like very.
Oh, you want to open your own Starbucks, right? That's why you want only premium shit. Fuck you, motherfucker.
Bro, but what's the point if like
Oh, well,
it's not even
it's gonna be better than that mocha thing that you're drinking right now. I would say for sure. And you want a
easy
compact,
get Italian cold
you
cup?
want a compact one, not a big ass one. You are not trying to sell or run a business, fucker. How many coffees?
Yeah.
How many cup of coffee you are gonna drink? More, not more than two, or maybe three
Hmm.
max.
20 bar super compact espresso maker stainless steel professional, bro. Gift it to me.
For sure, bro. For sure. I'm not even able to gift myself a fucking battery. Battery. Search for a battery, dude. Look for AMG 49H.
You have AMG?
No, 49. Yeah, this one. The second off. Yeah, this one. No, I'm
Group
not.
for it.
Yeah, I'm not even able to order this battery for myself, fucker. And you want me? This battery costs more than your coffee machine, fucker. I want to order this, but I'm right. I have other expenses to take care of first.
Just order it and then say that it didn't arrive.
No, I don't do that shit, bro.
Oh wow, brother. I know you.
I
I know you.
item
Fuck
might be
you.
defective. Item might be defective, right? Item can be defective, but never that thing. Until unless genuinely I don't get my product,
Hmm.
right? I will look up for a project. I don't lie,
I don't lie.
bro.
Bro, wait, I'm gonna make my tea first.
Successful.
And then we'll finish the fucking refining point instance.
Then we will do that quiz. That quiz will be fun. It's gonna break our ass.
Yeah,
We go AI, bitch. Oh, there's a 900 bucks coffee machine as well. Fuck.
I see.
But I know.
I know you love me. I know you care. Give me 5 minutes. Entertain the people, bro.
Oh, fuck you.
Do some shit and share your screen.
No, bro, I'm not gonna do any shit.
I know you're looking at stuff, vulgar stuff.
Yeah,
That's why.
I'm looking at, you know what, Amazon vulgar stuff. And my credit card bill, that is gonna be a vulgar stuff as well. Fuck DoorDash.
I think I should not drink tea right now. Let it be. Because I need to sleep early today. And I won't be able to sleep early if I drink tea right now. Because it contains nicotine. Let's finish the refining point instances. Come on. Fuck the tea. Come on.
What?
Let's do this.
Oh, primvares refinement using primvares. So now
Point instances. Truth. It's not primvars.
look at the second line.
Oh,
Fuck you, bitch.
I thought you were reading this.
Look at the second line, bitch. Refinement using primvares. Primvares using vertex interpolation will be applied per instance. See, per instance. Like scene graph instancing, you can introduce a lot of diversity in your point instances by using prototypes that read primvares. In the case of our packaging peanut example, our packaging peanut assets material network may read from primware peanut color primware. Authoring this primware on our point instancer could enable us to make each peanut a different color if we wanted to. So okay, let's look at the code. So we have over packing peanuts.
1 second, 1 second. Let me focus. Refinement using primvars. Primvars using vertex interpolation will be applied per instance. Like scene graph instancing, you can introduce a lot of diversity in your point instances by using prototypes that read primvars. Lot of diversity in your point instances by using prototypes that read. Oh, I see. In the case of packing peanut example, our packing peanut assets materials network may read from a primvare's peanut color. Primware authoring this primware on our point instancer could enable us to make each peanut a different color if we wanted to. I see. Uh-huh. So okay, over packing peanuts. But you said we cannot do over, and this is outside the prim point instancer.
How do we know that it's outside the prim? This code is half incomplete. That's why.
Bro, they are saying default prim world, and right after that, they are saying
So,
over. So I
so
am pretty sure it's outside that.
yeah, that's what I'm trying to figure out. I think we can find more below. But but it's in case, but it's saying on each instance. Okay, let's see. Let's take a look. Let's go deeper.
Wait, in the case of packing, our packing peanut example, our packing peanuts asset material network may read from primware peanut color. Yes, primware. Okay. Interpolation vertex. Authoring this primware on our point instancer could enable us to make each peanut a different color if we wanted to. Authoring this primware on our point instancer. Mm-hmm. Introducing new prototypes. If you want to introduce more variety to point instancer with additional prototypes, point instancing's explicit prototype pattern requires a bit more work than scene graph instancing.
Uh,
If you want to introduce more variety into a
we,
point
we can only
instancer,
we can only author primvars, or let's ask it. Can we author other things as well?
mhm,
Can we author other composition arcs as well? Let's see if it does or not. Well, I'm gonna assume yes. You're gonna. What about payloads and other reference files? Oh yes, we can definitely. This was a catch. My God, we would have been so wrong. Let me verify more things. How the okay.
If you want to introduce more variety to a point instancer with additional prototypes, point instancing's explicit prototype pattern requires a bit more work than scene graph instancing.
Wait. I think I get it. Why I was partially correct and partially incorrect. I think. Wait, let me just verify more. So can we author author over all the asset properties that were referenced? Author over asset opinions that were referenced inside the point instance. Can we author over all the asset opinions that we referenced? If we, I think if we can do that, yes, but the time okay, we do not have author over inside reference file.
Hmm.
My asset and then oh you have this product this. We can do box and then we perform opinions over the box from C. Ah, random prim that is also any over author on that path. But instance said the other way that we can't that what was it? Instance proxies are not immutable are immutable.
So did you see Elon Musk crashed out on Odyssey?
Wait, what the fuck is Odyssey? Is that a movie?
Yeah, I was talking about that yesterday.
Oh yeah, I was
He,
planning to go watch that movie, but then I slept the whole day. So fuck.
today?
Yeah, dude, I woke up at 4.
Bro, it's not even released yet. How would you have seen
Yeah,
that?
so I was planning that okay, I was gonna look into it and then maybe get a ticket because it's a Tallahassee, like over here, the cinemas are always empty. So it's a movie, right? Or it's something else? I don't know.
It's a movie, yeah, but like people are crashing out about it because it's a Greek mythological movie and like they have casted like a black woman to play a white or Greek character, so everybody is crashing out about it online.
Mm-hmm.
Lupita Nyong or some shit. You know, Odyssey. Look at this. Chris Nolan desecrated the Odyssey so that he would be eligible for an Academy Award.
Oh,
Holy, the life of Stephen Hawking.
it's a horror movie, but
Or this?
yeah, you said that it's a horror movie.
No, mythological movie, bro. Odyssey. Bro, how do you not know? Have you not seen Achilles or Troy or anything like that?
I think I have seen, but I don't profoundly remember them. But
Barack Obama.
the only
Ryan Gosling is Barack Obama.
oh oh okay
They
okay.
are basically misrepresenting, right? It was supposed to be a Greek character, white character, and a black woman is playing it. So Tupac, Ryan Gosling is Tupac. Bro, I'm head of Troy now. And this is reality. Legit. Rosa Parks. Helen of Troy. Helen of Troy. Yeah, see this like earlier movies represented like this, and then now she's gonna be playing the character. And Malcolm X. I don't know, bro. It's crazy. So what did you look?
I'm still looking. Start. This is not valid in the case of having any effect. We cannot. We can only apply over on the point instances, not on the server assets. Okay. Yes. So I was partially incorrect and partially correct. So I was correct about that.
Mm,
We cannot apply over over the properties of the
hmm,
that we're referencing. And on the prototypes that it is gonna render, but not, but basically not on the assets that the prototypes have. You get it or not?
what? I don't get it. Send me the thing. What are you looking at?
Just ask Perplexity the same thing that I asked. Oh,
What?
what else? Wait. Just select this. Just select
What?
this over packing peanuts thing.
Yeah.
Yeah, and ask them how can we author composition arc. No, no, don't. Okay, whatever. Why is this composition arc?
But it's not a composition arc, it's a specializer.
But it's a composition arc. Specializer is a composition arc, brother. Beyond
Uh,
basics. Oh, sorry, open composition basics.
yeah. Okay. For why is this composition arc? For the point instancer prim outside the def of the point instancer. Mm, isn't That invalid. So defining the prim, it's adding or overriding opinions on a prim that is defined somewhere else, typically in another layer or file. Def versus over refresher, def XFORM packing peanuts or def point instancer packing peanuts creates defines the prim and its spec type children authored attributes. Over packing peanuts says there's already a prim called packing peanuts in the composed stage. It's just contributing more opinions to it here in this layer. It doesn't re-declare the type or full schema. It says there is already prim called. Then why does it say it in this that we cannot do overrides over there?
You cannot do override on the assets proxies that you are referencing, but you can do override on the prototypes. You got it or not?
Wait.
We can do override on the prototypes, but not on the asset file that we're referencing directly.
Mm-hmm.
That is the catch.
Oh wait.
What happened?
This is also doing that overpacking peanuts.
Yeah, so you can do override over your prototypes and your point instancer. That's fine. That's what it says.
Mm-hmm. Okay. And what it can't do?
It cannot override over your asset files.
There is no way to do sparse overrides on arrays.
Yes. We do sparse.
But these are arrays.
So you are not overriding over arrays, right? Or where are we overriding over arrays? Sparse arrays, it says, not arrays.
What
Sparse.
is sparse?
Like picking individual array. I would just say that.
If you want to move even just a single one, you need to author the entire positions array again for
So
the
you
new
cannot
opinion.
you
Oh, okay, okay.
cannot do individual selection and do override.
Got it. Like we cannot just change two.
Yes, you have
We
to.
need to define 1 to 100 again.
Yes.
Got it. I see. Okay. Introducing new prototypes. If you want to introduce more variety into point instancer with additional prototypes, point instancing's explicit prototype pattern requires a bit more work than scene graph instancing. You will need to define an additional prim hierarchy for new prototype. Prim hierarchy as in this.
Yes. This is a
Oh, this.
hierarchy.
Huh?
Yes, 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 brother.
Mm-hmm. Define an additional prim hierarchy for new prototype. Add new prototype to prototype relationship. So adding a new prototype to the prototype relationship is this rel prototypes, and then they're gonna add this over here as well.
Yes.
Update proto indices to specify which instances should use the new proto. Okay, and this is the proto indices. So this is gonna be 0, 1, 2, and like there's also gonna be 2 if there are like 3
Yeah.
in this.
That's how the mapping works.
Yeah, refinement using visibility and deactivation. And what does it say? Refinement using primvars. It says that you just do over packing peanuts
Yes.
and then just define color 3F primvars peanut color interpolation vertex.
Yes.
So how is this refining it?
So you are basically selecting the peanut colors array and then changing the
Hmm.
interpolation of that array. So I think I'm assuming that peanut color is the property of the prototype.
Making a specific instance more editable or different from other instead of leaving it as shared copy. You can de-instance one point instance. That usually means you can de-instance one point instance, hide, prune, run, promote it into fully editable object. So the refinement isn't changing at all at once. It's about handling one instance, especially when you need unique behavior or replacing it with something else. A trade-off is that you lose some of the performance benefit from that one instance but gain control over it. So this is not refinement then. This is just making one of the prototypes. And also, is this creating a new prototype?
Go open an issue on and learn OpenUSD. Why is this not a refinement? They are defining it refinement. I'm not defining it refinement. They are defining it refinement. And refinement is the whole thing. So just go through it.
Okay, refinement using visibility and deactivation. At any point downstream, you can refine your point instancer by pruning or hiding instances using inactive IDs.
An invisible ID.
Inactive metadata, inactive IDs, metadata, and invisible IDs attributes. By pruning or hiding instances using inactive IDs. So if we define inactive IDs, what is it that we're going to define inside?
That I don't know. I think you're gonna see in the examples below.
Like 0, 1 or something.
I think the ID can be anything. Like that's a question that we will get to answer when we do like over here. We are using deactivating ID, so I think the ID will be like if you open the USD view, we will able to find it. The ID that is it is trying to deactivate.
Hmm.
Like in the exercise refining point instance, they are definitely deactivating an instance ID or something. So this ID is basically inside the USD view that we have.
Hmm.
This is a custom ID that you create. So you can create mapping of that ID. So for example, you know that on index 0, okay, if you go back in authoring point instance, go back into authoring point instance. I will show you where the ID comes from. Go to authoring point.
Authoring.
Yeah.
Yeah.
Okay, yeah, and then go up into this. Look, go up or down. You have to go down.
This is the
Yeah, a bit up, a bit up, a bit up. More up, more up, more up, more up. Over here, they talk about IDs, custom IDs, or optional IDs. Oh, up, up, up. Yeah. Each IDs is an optional attribute. So this is
Mhm.
these are the IDs that they're talking about over here. So
Mhm.
if you want to define an ID for your prototypes, you
Mhm.
do IDs, and then you will initiate an array, and then the first index you can say 105, right?
Mhm.
And that will be mapped to the first prototype, that is 0, directly.
Mhm.
That's how you ID your prototypes.
Mhm.
You can basically make that ID invisible.
Mhm.
So you can also ID your positions, your orientations, your scales.
Mhm.
And once you do that, then you can basically use invisible IDs to basically hide the box or whatever you want to do.
Mhm.
So this is where IDs comes from, and this is how you can use ID. So when you use invisible ID, you can say invisible
Yeah.
ID, and then the name of the ID or the numbering that you created earlier. So you can say that, okay, for positions, I created an ID. That's the
Mhm.
first index. The ID name would be 101 or P101. And then
Mhm.
you will pick up that position ID, right? That you
Mhm.
created, and then use invisible ID bracket, and then enter your argument of or the value that you want to hide, and it's going to
Mhm.
work accordingly.
Mhm.
So the best part of an invisible ID, as it says over there, is you can sparsely select like any index that you want to hide.
Mhm.
For the other positions we had that you cannot sparsely select any position, but in invisible ID,
Mhm.
you can sparsely select each position that you want.
Mhm. I see.
Yeah.
Mhm. Ah.
Yeah, let's go back to the exercise.
Mhm. We are not doing exercise. We are doing refining point
No,
instances.
no, below it, there is the exercise.
So, let me just read. A good rule of thumb is that you need to animate an instance on and off. Over time, you should use invisible IDs, otherwise, use inactive IDs. A nice feature of inactive IDs is that it can be list edited, so you can sparsely add and remove IDs. Refinement using promotion. Promotion in this case is what we call turning point instance. Give me 1 second. I'm just gonna.
Yeah, yeah.
capture license plate numbers, date, time, and location are increasingly being used by police. But civil rights groups worry the technology could be used to target suspected undocumented workers or women seeking reproductive health care. Home Depot and Lowe's insist they do not share information with third parties. Lowe's saying it only discloses your personal information if required by law or legal process. Home Depot saying we do not grant access to our license plate readers to federal law enforcement.
What the fuck are you watching, bro?
Thousands of
Just news. Shin Chan. Shin motherfucking Chan.
Mm-hmm.
What happened?
Nothing.
Ah, did you open up the OpenUSD, brother? Open
I
motherfucker.
was What did you want me to open? I was just checking the status in the speedrun application.
Oh,
It's still pending.
well.
Come on, bro. God, give me the glory for once. Give me some glory. What did you want me to open?
The exercise,
Oh, yeah.
which
Okay, refinement using promotion. Promotion in this case is what we call turning point instance into a full-fledged subgraph on the stage so you can override it more intuitively. In this example, we are creating a commercial, and we want to turn a packing peanut into animated character. We can use inactive IDs to deactivate the point instance that will be replaced by the character and then reference. Inactive IDs to deactivate the point instance that will be replaced by character and then reference the character into the same position. Now we can animate and override the reference character as we see fit. Exercise refining point instances. In this exercise, you will learn three key techniques for refining point instances, deactivating instances to prune them, promoting instances to fully editable assets, and using primars to adding shading diversity. Deactivating instances to prune them, promoting instances to fully editable assets, and using primvars to add shading diversity. You will explore how these techniques allow you to introduce variety and control into your point instancer while maintaining performance benefits, giving you the flexibility to customize individual instances when needed. Just beat it. I don't wanna be no, just be happy. Beat it. No one wants to beat the beat. Okay. And then in the horizontal center of the viewport, there is the box. In front of the palette is the point that we want to prune, we know the ahead of time. This is index 1228 in our point instance array. Okay.
Just beat it. Just beat it. Okay, I think in this we are gonna
This is 1228.
invisible
Yeah.
idea. So
So we are going to make this invisible, I guess.
yes, yes, brother. Yes. Invisible. Make that bitch invisible. Invisible. Invisible.
Interpreter. Oh, we're doing it in interpreter. Okay.
Yeah. So I think we have picked up the ID and then we are just gonna make it invisible.
We are not picking up the ID anywhere. We cannot, because this is part of the scatter. We cannot individually pick this.
No, we can individually. That's we are individually picking up the ID, dude. Okay.
Oh yeah, they have told us the ID. That's why.
I think we know we have defined. Like if we
Yeah.
the file,
Boom. It's gone.
yeah, baby. Let's try doing 1227 or something.
We won't find it, bro.
No, but I think we will be able to. Let's see what happens. 1227, something should happen.
Oh, this gone. This one went away.
What was it? Okay, let's do 6.
It was this. I saw it.
Okay, dude, I'm not able to see shit. When at what point it is.
Can we activate it again?
Yeah, I think we can. Let's do one two.
Oh, no, wait.
Yeah. Active.
Activate ID.
Yeah. 122. Yeah. Let's do it. Yeah. Let's activate this only right now.
1227. Wait, I'll activate this one.
Bam.
It came back, right?
Yes.
Yeah. I didn't see it, but okay.
You can do it.
No, it's fine. I get it.
There we go. We have just understood. Okay. This was the exercise, right? Or there was something else in this exercise. Let me take a look.
And then now we need to do this as well. Promoting
We have promoted.
in the following code
What if we don't want to prune this point, but wanted to promote it instead into full.
into a fully editable asset. Promotion starts pruning, but then you replace the prune point with the full asset. Let's okay. So I think what it's going to do is because right now we can see on the tree it's just scatter. I think when we run that code to promote it, we're gonna see it
But
as one of the assets on the tree
yeah.
in the.
Yes.
I
Yeah.
think
Oh,
that's what it means.
yes. 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 So let's run it.
Let's run some code to reference a new asset and place it in the same place as our prune point. We will continue with the point 01228. And let's see what it does. Bro, why can't I do backspace over here? What? Yeah, see?
Mm-hmm.
Cube box. Yes, I was right. Cube box A0426. So now it's individual. It's not part of the scatter anymore. So
Yeah.
it's out of the point instance.
Yeah. Sure.
And then compute instance transform. To get the complete transformation matrix for instance 1228 while automatically combining the prototype root transform and instance specific transform position velocity blah blah blah. Bro, 1 second. Hmm. Bro, I don't know how I ran out of water so quick. Hmm. Yes, bro.
Yeah, bro.
Are you gone? I thought you froze.
No, brother. Okay, so this approach uses compute instance transformation at time.
Let's look at this code like a little bit. So it's doing the same thing. It's setting the prim in box, stage path, box asset path. I think it's gonna then reference it. Yes, get reference. Compute the transform for the instances. This is more robust than get position attribute as it accounts for prototypes, transform and velocity. 2, okay. Xforms equal to pi dot compute. Instance transforms at time, USD dot timecode dot default, USD dot timecode dot default. We can ignore the mask to query the previously deactivated instance. Apply mask, USD geom dot point instancer, ignore mask. World transform equal to xforms, extract translation, rotation, and scale from the matrix. Translation equal to world transform, extract translation. Mhm. What does this mean? Xform equals to pi dot compute instance transform at time. Okay, this approach uses compute transform at time to get complete transform matrix from 1228, which automatically combines the prototype root transform and instance specific transform.
Bro, this is what I was talking
Position.
about. The matrix. Matrix of leadership. Optimus Prime.
What the fuck are you talking about, bro?
Bro, this is what I was talking about, the transform matrix. For instance, 1228, which automatically combines prototype root transform and the instance specific transform positions, velocities, orientations, angular velocities, and scale.
And it basically fetches all that data from the prototype to its individual
So,
asset.
so
That's what you.
now it's picking up that individual value from that
Yeah.
array to compute the transformation. Like basically, so for position, the index, whatever the index value at 1228, for velocities, whatever the value uh, that is present at the 1228 index,
Mm-hmm.
that is what it is picking up,
I
and
see.
then compiling it to create that the thing that we're looking at, that is the transform outside the
Mm-hmm.
box.
It's okay because point instancer is that way. Bro, do you think we should take the exam before?
Why are you in so hurry, dude? We should take as much time as we can to first complete the our quiz that we have generated, and then
Mm-hmm.
we will do it later. Then we will focus on, like, after a week, that okay, what is our status, because that quiz is gonna basically give us a baseline. Okay, how are we doing and what are we lacking?
Mm-hmm.
Take your time, bro. Take it. We will take our time. We have that specific date by God's grace. That
Mm-hmm.
was selected by God's grace.
Mm. Beat it, beat it, beat it, beat it. Me just wanna beat. Just beat it, beat it, beat it. I think bro, is Databricks on the stock market?
I don't know, bro. Just ask Perplexity right over there.
I think it's gonna IPO, right?
I don't think so, dude. Databricks has already IPO'd. I would guess not. Yes, it already exists, maybe.
Still a private company. It has not IPO'd.
Yeah. I think they are pre-profitable before that, or
They are very profitable by
that's why they are not going maybe public. That they don't want to share their profits.
data lake. Mm-hmm. Mm-hmm. One second. Okay. Come on, bro. Come on.
Yeah, bro.
So to get complete transform matrix, you are saying it basically fetches it from the scatter prototype over here, and we can ignore the mask to query the previously deactivated instance. Apply mask USD geom for instance or ignore mask world transform xform 1228. Extract translation rotation and scale from the matrix. Translation equals to world transform extract translation. Uh-huh. And this is put into translation rotation and scale. Mm-hmm. Bro, explain this to me. I know they are extracting it inside this,
Mm-hmm.
but where is this going? Oh, okay. Apply the computer transform to promote box using external API. Set translation. Oh, this is where it's getting transformed. Okay. This is where it's getting the new values or
Yes.
the values in the new X form.
Yes.
Okay, got it. This is still slightly simplified because we did not account for the point instancer Prince transformation in this case. It's okay because point instancer is at origin. Mm-hmm. I see. The box looks like it did before in the viewport, but now we have a new prim hierarchy in the scene graph where we can author new opinions to manipulate this asset. Yes. So now it's out of the point instance, right?
Yes.
Yeah. So now it's, yeah, okay. Using primvars for shading diversity. Now let's look at the third refinement option. So this is not exactly a refinement, right? This is just like getting the asset out of the point instance. It's how is it refinement? It's not improving anything. It's not optimizing anything.
So, but you are able to pick
It's
up.
just increasing the editability.
Yes. So I think that is what the refinement means.
Refinement
But
means.
one of the way
Okay.
was we were able to remove or make an
Mm-hmm.
object invisible. Let's say we have multiple objects. One of the object is covering another object. We want to take a look at that object, so we can refine the view and make that object invisible and not to render.
Mm-hmm.
That is where this thing kicks in, I would guess.
Mm-hmm. I see. Hmm. Now let's look at the third refinement option using primvars. In this case, we're going to use primvars cleanness again. Cleanness. I don't know what the fuck that is. This is a custom primvar that we created for the CubeBox A0426 asset ahead of time. It's the same primvar used for exercise hierarchical refinement. Yes, I remember this. Hierarchical refinement using primvar. Yeah, we were setting the values for this. Okay. Run the following code in the interpreter for range 2000. No, wait. This code creates primvar cleanness on our point instancer, but it uses vertex for variability. This means is that each item in our array will be assigned to different point instancer point. We are using random library to set 2000 random values. But nothing changed in the viewport. This is because primvars are inherited, but only if a value hasn't been set by a descendant. The descendant opinion on the prototype that we referenced is stronger than ancestor opinion of the point instancer. Mm-hmm.
Third refinement, bitch. Third refinement.
I don't get what this means, but nothing changed in the viewport. This is because primvars are inherited.
So let's.
Only if value. Okay, I'll run this first. Wait. In the interpreter. I think we should make our own compiler.
Yes, brother. Then we should make our own computer, OS, and everything.
You,
Computer.
yeah, you got me.
Yes.
Exactly what I was trying to. And then we should make our own programming language also. Bhosada plus plus.
Nice.
Any recommendations for what we should call our new programming language? Brother, tell
No,
me, bro.
I don't have any. OpenUSD. I will just go, stick with OpenUSD for now.
I see. The FPS on this shit is very bad. Hmm. I think I know what that is doing. Oh, I see. Okay, this code creates and our array will be assigned to a different point instance or point.
Yes.
What? Yes. What does that mean?
What this means is,
If you say the same shit again,
if what it means is,
it will be assigned to different point instance or point.
yes, that was I was gonna say, but let me take a look. The code creates on our point, but it uses vertex for variability. What it means is each item on our will be assigned to a different point instance. We are using a random library to set 2000 random values. Okay, so let's take a look at the code. So we are
Mm-hmm.
using a float array for cleanness, right? So we have a cleanness array that is gonna be taking in vertex as a
Mm-hmm.
square, like the token for the point for interpolation, right? And then we have our float array as well. That's what we are gonna define. Right?
Mm-hmm.
On a what That's clear. But now what it says over here is on each item on our array will be assigned. Okay, so now since once we have created that array, as how the point instancer works, each
Mm-hmm.
value in that array will be assigned to a different point instancer point. That means
Mm-hmm.
we if you have let's say your prototypes, right?
Mm-hmm.
Prototypes will have 0, 1, 2, 3 as array indices, right?
I
So
don't get it. Wait. Start from
you have
scratch. What did you?
okay, imagine the cleanness array that we have,
Yeah.
and that array has a length of 2000,
Yeah.
as it says over there,
Yeah.
right? And you have prototypes
Mm-hmm.
in your point instancer,
Yeah.
and you have, let's say, 1000 prototypes, for example.
Mm-hmm. Mm-hmm.
Each prototype will be mapped directly to that index of that cleanliness array. So
Map directly to that index.
yeah, to the index of the cleanliness array. So
Why?
point what?
Why? Why would it be mapped over there?
Because that's how point instancing works, brother. That's how point instancing works. Like for
Wait, you're saying all the. So you're saying over here, all the if there's a primware called cleanness,
yeah,
that's on an attribute, let's
yes,
say. And you're saying all these will be mapped to that
to the array one on one.
on that array. Okay.
Yes,
Okay.
one on one.
Because it's a
To a
yeah,
box,
because it's a primware on the point instance.
yes. So a box would be mapped to one index of that cleanliness array. One element, I would say one element. That would be much clearer.
Mm-hmm.
So one box over here represents one position
Mm-hmm.
index in position index array, and that position index
Oh.
array will be mapped to that index of that cleanness array. So if the
Mm-hmm.
position index of the box is set to 100, and the
Mm-hmm.
cleanness array has an index at 100, and it has some value, let's say 300, it
Mm-hmm.
will be directly mapped to that position. That's how position instancer works. So it's going to be different
Mm-hmm.
for each and every position. That's what it is saying over there. And based on that, we have 2000 random values.
Yeah.
We have 2000 random point instancer point,
Mm-hmm.
and that you will be mapping 1:1.
What this means is that each item in our array will be assigned to a different point instance or point. We are using random library to set 2000 random values. This code created around using vertex for variability. What this means is that each item in our array will be assigned to a different point instance or point. We are using the random library to set 2000 random values. Okay, so it's doing random dot uniform. And this is range from point 3 to 1.
No, that is your element index. That is your range is 2000.
Element index.
Yes. So that would be the element on the first index 031 0.3 comma 1. So you are using random dot uniform. So you will have random uniform values on every element. You will have random uniform values on every element. So if you have 2000 elements in your array, so they will have,
So what does point 3 and 1 mean?
that is a randomness that you are going to create. So point 0.3 and 1 means the range. So you will have
That's
to.
what I wow, that's what I fucking said first, and you
Oh,
said no.
oh,
I
okay.
said I asked this point 3 and 1 the range. So
Oh,
every all the values are gonna be between point 3 and 1.
yes.
You fucking bitch ass. What this means? We assign different point instance a point using random library to set 2000 values. So every point in our 2000 point instances points will get a primvar cleanness, and all of them will be randomly assigned a range, like cleanness range from point 3 to 1. But nothing changed in the viewport. This is because primvars are inherited, but only if value hasn't been said by a descendant. The descendant opinion on the prototype that we reference is stronger than the ancestor opinion of the point instancer. World scatter weaker. Prototypes, cube box, okay, stronger. Fortunately, we can block the prototype's opinion to complete our tasks.
We
Scatter.
we are gonna open something.
Does it want to- That didn't run or what? It did run. What happened then? Cube box, but I'm not seeing anything. What? What is it trying to show? Scatter? Oh, wait. I think it's because the setting is not activated over here. Show abstract prims. Yeah, prototype. Yes, 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 yes.
Oh, okay, okay. What are we seeing? Beach.
Cube box. Okay.
Nice.
Okay, so now we're gonna run this. Nice. Okay, now they're dark.
I see. Dark, darkest, darker.
Mm-hmm. What is this doing though? Oh,
What happened? What is it doing?
this is basically getting the prim path and then it is blocking that cleanness attribute.
Mm.
That's why it's becoming dark. Point instancer can finally take effect.
Nice.
Mm. Earlier, you created a primvas cleanness on point instancer itself with per point values, random dirtiness levels, but nothing changed visually because the prototype already had its own primvas cleanliness value, which is stronger in composition hierarchy. NVIDIA, okay, by blocking the prototypes primvas cleanness, you remove the stronger opinion, so the inherited firmware from the point instancer now wins and drives the shading of each instance. hmm Got it. Conclusion.
You have successfully learned three key techniques of refinement: deactivating, instancing to prune, promoting instances to fully editable assets using primvars to add shading. Oh wow, wow, diversity. Wow, wow. We have done it. We did.
These techniques give you the flexibility to customize individual instances when needed while maintaining the performance benefits of point instancer to making an ideal solution for large scale scenes that require both efficiency and control. Instancing FAQ. Bro, last topic of Learn
My
OpenUSD.
God, I
Last
think
topic.
it's small.
Huh?
Yeah, it's small as fuck. That's it. What is
That's
the difference
it.
between scene graph and instancing? Scene graph instancing is going to be composition based instancing, implicit prototypes defined from composition arcs, instance and instance descendants identified by a path. Each instance has an instanceable prim that's editable. But the subgraph instance proxy is read only. This is the most critical thing.
Yeah.
Transparent de-instancing, good for reusing complex component shell assemblies robot. Point instancing, schema-based instancing, explicit
Yes.
specified in scene description, instancing,
Yes.
identifier via index. That is most important. That's where prototypes kicks in.
Mm-hmm.
Invasive de-instancing may be combined with scene graph instancing, good for massive number of simple items where the overhead of an instance outweighs the benefits of reuse. Woo, woo, woo.
Example leaves on trees.
Like the leaves of tree will have different kind of positions, and then what it will have, it will have different kind of positions, orientations,
Mm,
and what would the other and color would be the same. Maybe the shape can also be different, right?
oh, like that. I'm gonna show you one second. Like this. Position, orientation, and scales. These three.
Mm-hmm.
We are done with Learn OpenUSD, brother.
Yes, let's do the quiz and then we will end the stream for today and then we will just do quizzes and some recaps on like whatever weak points that pops out.
Pops out. Damn, bro, we fucking finished it.
Fuck! You did it.
And it's all documented on stream.
And then just we have to also document our OpenUSD certification.
Nobody can stop us now. What do you want me to open the PDF on this?
Yeah, open the PDF on this, and then
How many questions are you doing?
third. How many you want to do?
All.
All will take a lot of time.
Let's start and then we can see.
Yeah, let's do 20. Let's aim for 20. And then from tomorrow we can do like all like 60, 60. Like spend
Hmm.
more time on the quiz and less on other things.
Hmm. All right. Question 11.
Composition. Which shape? Open that. Make sure to have that pen so that you can mark which
One second.
statements. Which. What the hell are you doing?
Bro, why is it 2 page? I want to do it in 1 page.
But 2 page looks good, bro. 2 page looks good.
It doesn't look good to me.
Ah.
I want to zoom in. Yeah. Central.
Which shape?
Can you see pen?
Yeah. Describes. Do
Oh shit.
you have a do not do you use the no, not this, not this. I think you do not have the squiggly one. Squiggly. Squiggly. Now for some reason we do not have that. Fuck. Oh yeah, we can
Oh, we can.
yeah, we
Yeah, I can highlight it.
can highlight it. Yeah.
Why is it fucking going so fast on this? Okay. Select two options. Which statement correctly describes how sublayers behave within a layer stack? Sublayers behave. Okay, sublayers are ordered list, where the first list is stronger than the last
That's
listed layer.
good.
That's correct.
So yes, A.
A, and then when a layer is composed as a sublayer, all of its contents are added to the destination layer in an include fashion without any path remapping. Each sublayer is grafted onto single destination prim, undergoing a prim name change, and path translation.
No, C is incorrect.
Mm,
D. A weak sublayer always wins. D is also incorrect. So we will go with A and B.
yeah.
All right. Question 12th. While debugging a prim, you want the list of prim specs contributing to the prim's metadata, and separately the list of property specs contributing to one property's value. Which API returns these two things?
You want to list the prim specs contributing to prim's metadata. Okay.
And separately a list of property specs contributing to one property's value. Okay.
So why is it? Oh my god, bro! Your fucking shit is.
Dude, not it's not me, it's you, bro. You are not able to manage it properly.
Bro, I'm scrolling it like
Okay,
this and then
bro,
it's just
you're
going
not
to the
able
next
to
page.
scroll it. Then that's also on me, you piece of shit.
Yeah, bro, it's on you.
That's your incompetency. Incompetent.
Yeah, sure. So why does
What?
why have they given us the code snippet?
We are go to question. I don't know. Like I don't know, bro. Move it. What's on the other page? Go up. You have the
This.
options over here. That's why I was asking you to have 2 pages so that we can view it
Oh
side by
my
side.
god, bro.
Fuck
Fuck
you.
you, bro. Your fucking incompetency has led to
Yes,
this.
yes, go back. Oh fuck.
Because you
Oh,
need to serialize the question properly, bro. You need to work with
we have
AI
serialized it.
well.
Okay, the serialization is correct. It's
But
11 and 12,
we
right?
have to, yeah,
What did
in
you
the tool
him?
view also I have to scroll.
Yeah, it's
Because
fine.
it's over here, your bitch ass.
Want a list of print specs contributing to print data and separately list of property specs contributing to one property value, which API return these two things. So inspect stage, okay, get print stacks gives you the stack, get attribute gives you the display color. Oh, so I think I know. So it's gonna be. Let's go. Let's move to the options we have.
Stage.get prim path. I am not understanding why they have given the
Dude, I don't know. A gets returns, print specs contributing, returns as USD producer, filter from. I think both are return. I think I would go with A. Let's do this question. Look, not every question is gonna be perfect. I would say some of so I think these are the questions that I'm gonna flag it.
you are not working with AI properly, you know.
Bro, that's my bad. It was my first time.
Yeah, you need to, improve how you work with AI.
Yeah, bro. I'm just a day. One day I will become you dude.
Uh, so what option are we selecting?
Hey, I will go with A.
Just because it's the longest.
Yeah, bro. That's the longest one. That's why.
Okay.
Data model.
Data modeling, a USD file does not explicitly author meters per unit or up axis according to OpenUSD's fallback behavior. How are these interpreted? Fallback is one. Are you sure?
Yes,
But
brother.
up axis is Y, I think.
Oh yeah, this is wrong. The answer is wrong. Like technically, A
I
should
think it's B.
no B cannot be like 0.0.
0.01, right? I think I read it
No, but
somewhere.
fallback always goes to 1 meters per unit.
Are you sure?
Yes, bro. Go look into the documentation as well. I know for sure. The options are incorrect over here. We have the link. Just click on that link. Just click on the link below. Yeah, click on that. Yeah. Oh, it will open up. Click.
No, this is
Oh
shit.
no, bro. It should do. You know. Okay, wait. In which thing you have open your thing? Yeah.
Preview.
I have also the same thing on preview for some. Okay, you have something overwritten over that. Just copy that thing.
You fucking piece of shit.
For me, it
You have
works, bro.
not.
I don't know for some reason it doesn't work for. Yeah, there we
Oh,
go.
now it works. I don't know why.
Yeah, take a look at it. It will say it you over there. Where, dude? I'm not able to see.
Oh.
What are you seeing? Yeah. So you see up axis or typically Y or Z. Oh, that's why.
So it can be A over here.
It can be and you can see for example means there is but while one means contents in meters. But what is the default? Yes, see it's the fallback is 0.1. Oh yes, yes, yes. Yeah, it's gonna be B, it's gonna be B, not A, it's gonna be B. It's gonna be B. Yeah.
Where is the fallback?
Note, take a look at the note. Yeah, it's gonna be B.
Yeah, I told you it's 0.01.
It's gonna be B. AI. AI, bitch.
The fuck, bro? Apple, your UX is so shit.
Dude, I think why are you not able to edit it for some reason? I am able to. Okay. Which are the primary advantages of using USD composition in production pipeline?
Multiple users can collaborate on the same scene without conflicting at the,
A or A as well.
but it doesn't say oh select too often. Layers enable down structure editing, making it yeah. Composition hierarchies no. Okay.
Pipeline
Pipeline development
tool
tools.
sets stage units in Python, but authored metadata does not take effect for geometry consumer, which calls correctly set the up axis and meta unit on a stage. Okay. So A setup and then stage meter per
I'll
unit.
be back one second.
Stage setup, stage set per kilogram for both axis and scale.
Yeah.
A, I would go with A.
A tool sets stage units in Python, but the authored metadata does not take effect for the geometry consumers. So what calls correctly set the axis up and meters per unit on stage. USD geom set stage up axis, which calls correctly set up the axis and meters per unit. Mm, I think USD geom set stage up axis meters per unit. Mm-hmm. You're saying A.
Yeah, I will go with A.
USD geom set stage meters per unit. Geom stage doesn't do that.
Wait.
I think
Geom does not. USD dot stage dot. What does it say over here? I think it should be. This is the same file. Fucker. That is the same file that you have to open. Yeah, go up.
uh-huh.
Go up.
Mm, it doesn't say anything over here. USD geom
Geom,
linear units.
yeah. Geom, it's Geom, I know. Yeah, Geom linear. So it's gonna be Geom because we are using geometric.
Yeah, it's gonna be a tool sets stage units in Python, but the authored metadata does not take effect for geometry consumers. Which call correctly sets up the axis in meters per unit on the stage. Set stage meters per unit. Yes, USD. Okay, you're right. 16. Okay, customizing your USD pipeline.
Needs to attack.
Your pipeline needs the to attach a consistent set of physics properties, mass friction to any existing mesh without changing their type name. What kind of schema should you author, and from what should it inherit?
Hmm. Attach a consistent set of physics property, mass and friction, to many mesh frame. So, and without
And
pipeline, what kind of schema should you author from? So, an applied schema inheriting API schema, or concrete data type schema, an abstract type
A.
schema inheriting.
I
Uh,
will go with A.
an abstract type schema inheriting one USD per point with and multiple concrete, which physics properties mass. I would go with B.
Concrete typed is a schema from USD typed set via type name.
Yes.
Oh, without changing their type name. Hmm. Ah. Hmm. What?
We'll mark it with some other color, right? Where are we? We will look at the documentation later on. Let's first focus on marking it. Yeah, mark mine. Yeah, I will go with B. Yeah. Question
I
7.
think yeah, it can be B over here. Yeah, I think because USD. I don't know.
Okay. Yeah, let it. We will. That's why we have this practice quiz. Data
In a
exchange.
two-phase extract, then transform data exchange pipeline, where do export open option such as restructuring the prim hierarchy or merging meshes belong, and what is the round trip best practice. In a two-phase extract, then transform data exchange pipeline, where do export such restructuring the prim hierarchy or merging meshes belong.
A.
Um,
In transform.
I don't even understand what the question means.
Bro, it's asking you about data exchange pipeline. You remember we were doing.
Oh yeah, 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 yeah.
That's what it's
Uh-huh.
asking about.
Where do export options such as restructuring the prim hierarchy or
At
merging
what
meshes
point
belong?
you will get those options. So that's why I think in transform you will get those options better, not in extract, because extract can have a transient data.
Mm-hmm.
18th, visualization for a distance slide below with only a rotation authored along for distance.
For the distant light below, with only a rotation authored along with which local axis does a
Use
USD distant lux emit by default before. Oh, we have done this, I think, along by.
before.
Oh, along Z, sorry.
Oh yes, along z axis. Yes, yes, along z axis. Question
Why
9.
is this negative Z?
Oh, wait, which by default? I don't know, but the z axis is the correct one for some reason.
Oh, that would be.
Compose. What does default prim layer method provide? What happens if it is unset when the layer is referenced? It names the entry point when the layer is referenced. The unset layer is also an empty. A.
Yes. A developer wants to enable verbose internal USD diagnostic output for the specific subsystem using symbolic flags set through an environment variable like one shown, which facility provides this. TF debug, USD checker
E.
with flags. Yeah. C.
Yes. Debugging and troubleshooting a pipeline temporarily needs to surpass one layer's contribution to compo.
Bro, why are you always reading this shit? It confuses the fuck out of me, and it's just a pipeline.
A pipeline temporarily needs to suppress one layer's contribution to compose stage without deleting it. From which API does this? Oh, this is something. I think A. I would go with A.
Mute layer.
Yeah, like nothing else makes sense. A.
Oh, what the fuck, bro? Why the fuck is this turned on all the time?
Delete that. I think you have some layer over that. Okay, delete this. Yeah, press delete on that. Yes. Yeah, there we go. Okay. Now, which scene graph instance refinement technique results in a new prototype being created?
Oh, we have done this.
Which scene graph? A. Oh, we have two options. So A is gonna be one, and
A
A.
and B.
Yes, A and B. Question 23. Pipeline development. A pipeline tool must compose an entire stage down to a single layer for delivery, removing composition arcs and proprietary file format dependencies. Which operation is correct and what distinction matters? USD flatten composes whole stage to one layer and removes arcs. This differs from flattening a single layer stack. Flattening a layer stack composes the whole stage. USD stage.flatten only merges sublayers of the root. C. SDF change log flattens the stage by batching all arcs into one layer. Okay, wait. Your USD stage.flatten use the entire stage into single layer, removing composition arcs and proprietary.
I think A.
Yeah, I'm also thinking A.
The options are really bad, bro, because none of the other options are making any sense.
But B can also flattening a layer stack composes the whole layer. Flatten only merges sublayers of the root.
Bro, it says here this differs from the flattening a single layer stack.
Uh,
It clearly says here.
okay, we will go with A. But it's so for someone who doesn't know, I don't know. So I think both can be an option, right? But wait, no, not both can be.
Bro,
Wait, wait,
it's saying removing composition arcs and proprietary file format dependency.
we can also
USD
do that.
stage.flatten composes the
Right. So no.
whole stage to one layer and remove arcs.
So with the whole shit. So but C, look at C. SDF change block flattens the stage by batching all arcs into one layer. Set right. So that could also be an answer.
HDF change blocks flatten the stage by batching all there.
But I think
But
I will
that
go
just
with
looks wrong.
A. Yeah, let's go with A. Okay, I will work.
Setting a new editor automatically flattens the compose result to say.
Visualization. OpenUSD
Oh,
shift.
this is in glossary,
Yeah.
not in Learn OpenUSD.
So I just told it to do everything, parse everything using the browser. OpenUSD ships with a render delegate that provides an out-of-box real-time way to visualize the USD data used by USD View. Which render delegate is this? Ooh, this is an interesting one. Which render delegate is it, bro? I think it's Arnold. I think it's Arnold. But that is that
I've
a
also heard Arnold.
no? But it's is it a render delegate? Wait, Arnold is Arnold render delegate? HD Storm, uh, bundle protection. I think it should be HD Storm.
Oh shit, this is cool.
Yeah, I think it should be a HD Storm. Storm. Storm.
But I don't see it anywhere over here.
It's
Oh, I did see HD
HD
Storm.
Storm.
Yes.
Yes, it's HD Storm. Storm. 25th.
Debugging and troubleshooting. Select three options. Opinion.
An option authored in one layer does not take
Opinion, bro, not option.
an opinion. Oh my God, bro, I'm blind. Authored in one layer does not take effect on the compose stage. Which are the plausible root causes? A. B. The prim path no longer matches. The layer has been muted. C can also be one. C as well. And what would be the third? Prim is no longer matching references. USG composition picks opinions at
I
random.
think B can also be one.
And B like D and E doesn't make sense.
US,
Is B.
USD composition picks option opinions at random. No, yeah, B.
Question 26. Data exchange. You are importing geometry from an OBJ file into USD. The OBJ uses one global vertex list. Which set of actions currently rebuilds the mesh for USD? Data you are okay. Rebuilds mesh from USD. Which set of actions? A. A.
All the other options don't even make sense.
Uh,
Which statement correctly distinguishes is a typed schema from API schema? Prim has exactly one is a schema, while many API schemas may be applied to the same prim. Yeah, A. And
yeah.
API schemas are set to prim. Bro, I think all the answers are mainly A in your quiz.
Okay, bro. I don't know. Yeah, I'm gonna work on that. I will ask it to
Yeah,
add the
both
reference
is
tag.
a, and bro, why are you generating PDF? Like, okay, generate PDF, but also ask it to host it on your server or something, and then share the link, and then we can do it.
Okay, I will do.
Just the way I was doing it.
Yeah, yeah, I will do that. Okay. Yeah, let's 28th. Last two. Material authors want the same USD preview material to be easily customizable so downstream artist can tweak its look without editing the shading graph. Which practice is best supports over here? Expose a key shader input such as diffuse color and roughness as override parameter on the material. Author, yes, A is gonna be, yeah, there's only, oh, and two, author a separate material for every possible hardcode, connect the service output. I will go with D, A and D.
Yeah, that's yeah.
Hmm.
So all the others are irrelevant.
Which statement should inherit arc and class specifier? They are typically authored with are correct. Wait, which statement about inherit arcs and the class specifier they are typically authored with are correct? Oh, okay, okay. Modification to source prima A is gonna be that.
Made modification to inherit source from our broadcast. Yes, and applied to all prims and inherit it within the context.
A is gonna
Data does not change image render.
be inherit arc treat isolated copy of source. So later, no, C is incorrect. Hmm.
In one scenario, automatically after that uses yeah, I think D.
Just D. Question 30. Last one, but not the least. Which statement best describes the role of data exchange in an gets in into out? Or if it gets data into and out of USD and it's typically lossy since every source data models maps to 101. I think A. Most of the answers are A. Fuck.
No, I think this could be B.
Now it's gonna be A.
It gets data into and out of USD and typically lossy. Which statement device describes the role of data exchange in? Oh, role of data exchange, my bad.
All right, let's review our answers. Yeah, I think can you open the PDF?
Pretty.
Yeah, you can open the PDF in Chrome. Like click, go to your Finder and ask it to like just you can click on the yeah. Go to your Finder. No, no, no. On your like your MacBook
No,
Finder.
I know. But I am just seeing if I can do it from here as
No, you
well.
can do it from over here. There is way, but you have to basically give the location of your file. So it's better to open it using Finder. Much easier, quicker. Or just copy the relative path, or copy the path of the thing, and it's gonna render over here.
Where is the copy? Open.
No, bro, you cannot do that. Just go into Finder. You have to copy it from Finder.
Copy. Here.
It's not gonna copy the file path, brother. Is there?
But I don't know where it is in my Finder and I'll have to find it. I just opened it from your iMessage.
Oh,
Right.
okay, then it will show in Finder. Like go to iMessages and it will show in Finder, or you can save it in your downloads.
I don't. No, bro, I don't see it in my Finder at all.
Then go to your messages and save to downloads.
Bro, fuck you.
What?
Bro, what the fuck? Let's just do it over here, bro. I don't want to fucking find it in my thing. Okay, 30 was A, 29 was A and D, and 28 was A and
Dude,
D.
just open the Finder, dude. It's gonna be quick. Okay, go to your
No,
iMessage.
I don't want to do it. I don't want to do it. I fucking tried it. I don't see the option to download it in my phone.
Okay.
Save to downloads, Finder, downloads, open with. Okay. Okay, what did we do? 11th, right? Okay.
Yes.
So 11th is correct.
11th is AB. A. B.
12th is correct. B. 13 is correct. 14 is A and B.
Yes.
15th is A.
Yes. 16th.
16th is A and B.
No,
What?
like B was my answer. 16th is A, so you were correct. I was saying B.
Yeah.
Yeah, so okay, and applied schema inheriting. 17th is A. 18th, what is 18th? 18th is
B.
B. 19th
Correct.
is A. Wait, 19th is A? Yeah.
Yeah.
And 20th is A. Wait,
C.
20th is C? Oh,
We did C.
oh.
USD checker. I thought it was gonna be wrong because yeah, we USD checker is just a command line thing,
Mm-hmm.
and we basically TF debug with flag set via TF debug environment variable or TF debug set debug symbols names. I don't know what this is. I should open the thing, right? Why is it referencing your
What?
debugging? It's referencing this for the documentation that it has given it source.
Yes, because that is one of the source, I guess. That's why.
Yeah, but like where in this is debugging TF? What is it? TF debug.
Do Command F on this. You will find it. Do Command F TF debug. Yeah. Dude, where are you typing?
Right. This fucking shit Apple. Where is it?
TF debug. Hmm.
One of one match. But where is it? Oh, here. TF debug. Work with diagnostics for debugging the and profiling. So I think
So this is what
API docs
created.
tutorial.
No, it created the question out of that line. It created the question out of that line, I would guess.
TF diagnostic.
In search,
MR delegate.
TF debug in this.
Nothing. Bro, I don't know. This is quite fucking. Let me ask. Okay, TF debug class with flag set. Get debug symbol names. Set debug symbol names. Yeah, it's pretty much correct. Okay, got it. So one answer is wrong. 21 is A again. Fucking A.
We have most.
USDC. And then 22 is A and B. That is correct.
Yes, 23 is
23 is A. 24 is A.
20,
25 is A, B, C.
26.
Yes.
Wait, let me just.
A. 27 is A. 28 is A and D. Yes. 29 is A and D. Oh, 29 is wrong. 29 is A and B.
Oh, Hydra does. Okay, and OpenUSD mostly. Hydra does not image render a prim with a classifier on any of its descendants.
Mm-hmm.
What does the explanation says over there?
Source. Exposing overridable input lets artists customize without rebuilding the graph. Okay. And connecting the material surface, exposing output to the USD preview shader produces a valid usable network, pre-baking the material per combination and hard coding the values, both prevent easy customization, delete. I don't know what that means.
And what is the last one? I think apart from it, 30 is a.
Yeah, that is right. So
Okay.
only 29th and
Mine,
this one
mine
is
was
wrong.
16th. I had
So
to.
18 out of 20 were right.
Oh my god. 17 out of.
Hmm.
Fuck.
For you.
Yes, fuck me. Okay, I have noted this down that now the question, now they won't have A as.
Bro, make it random,
Yeah,
like
yeah,
equally distributed random. And what
Oh, back. All right.
All right, bro. We can end the stream now. Let us end the freaking stream.
Whew.
आज तो बहुत ही कम व्यूज आए